We shall now go straight in. Here we are in the Google Cloud platform. Let's now go ahead and deploy our model. Firstly, we'll need to create a new project. So right here, we create a new project. We'll call this project Neural Learn Sentiment Analysis. There we go. We create that. Here's our dashboard. We have the project name, project ID, project number, resources, trace, and all these other features right here. So we can scroll and we have that. Now we have the activity and the recommendations. In order to store our model, which we just saved, we are gonna use buckets. So simply here we just search buckets. There we go. We have the cloud storage. We'll be able to create a new bucket. So for now, we have no bucket created in this our neural learn sentiment analysis project. So we create a new bucket, which we shall call, say, simply conf 1d bucket. And you could always get into this to select or to manually configure this bucket. So for now, we just create this, and there we go. Our bucket has been created. What we have to do now is to upload the model files, which we have saved here. So we have these variables, we have this tool. There we go. See, it's downloading, or it's rather uploading this into the bucket. There we go. We've uploaded the two files in this bucket, and now we could go ahead to the Google Cloud function. So we'll simply have cloud function. There we go. Now we could create a function. We'll call that neural learn sentiment. That's it. The trigger type is HTTP. You could choose other trigger types. We are going to allow unauthenticated invocations, and then we could simply save this. Go to the next. In here, we'll get into this source code path, or rather in this runtime, where we're going to pick out Python. So we have Python 3.7. That's fine. Now, once we pick this, you see this changes actually. So if you go back to Node.js, you see we had index.js, package.json. Now going back to Python 3.7. There we go. We have the main.py and then the requirements.txt. By default, in this main.py, we have this hello world, which has this, or which takes in this request, which is an HTTP request. And based on this request, we can take certain actions. In our case, this request will contain our review. So here, as you can see, we have this request JSON, which takes in the request that get JSON. And then if this request contains some arguments and message is one of these arguments, we return this. Else if the request, or if we have request JSON and the message is in request JSON, we return this. Else we just return hello world. Now we shall take all this off, and here's what we have now. Let's put this out. Let's enable this API. So here we simply click on enable, and that's fine. We've enabled that already. We have this import right here. We import TensorFlow. From google.cloud, we import storage, we import the regex, and we import string. The vocabulary size is defined, just as in the Jupyter notebook. The sequence length defined, embedding dimension defined. We have this preprocessed sentence method, which we've seen already. The vectorized layer, which we've seen. Let's expand this. We also define the inputs, the embedding, and then we have our model right here. So that's our model, which has been defined. And then we have this other two methods. That is the download blob method and the handler method. This method takes in the bucket name, the source blob name, and the destination file name. Here we use the storage, which we've imported from google.cloud. Scroll down, and then we create this client. With the storage client created, we get the bucket. We create this blob based on this bucket right here. We have bucket.blob, and then we have blob.download to file name, wherein we pass in this destination file name. Then this is printed out, which is useful for logging. Now the next function is the handler function, which is like our main function, and we shall specifically declare it as our main function right here. So we have entry point handler. So that's why, as you could see here, it's in this handler that we pass in this request right here. Now we've defined our model. We defined this download blob method. We see here we just simply call this method. We have conv1 the bucket, which is our bucket name. Even here we have conv1 the bucket. We specify all the files that we uploaded, the variable index, and then this variable data file right here. We also given this destination file name, which takes the same file name as this source blob, but with a different location, as you can see right here. And then we load the weights. Note that this model load is only done when we are doing a cold start. Now once we've loaded our model, or we've loaded our weights, we now have this request JSON, which looks like what we had from the hello world method we had when this main.py file was loaded initially. So we have this request JSON, request.getJSON. The review is simply this request JSON review right here. So in this request, as you could see, from this request we're going to create this request JSON, and from this request JSON we are then going to extract the review, and then this review is going to be converted into a string. So from this we could simply print out this for login. Here is a review, and we print out the review. Then we have the test data, which is simply created similar to what we had in the notebook, in which we had seen how we could use the dataset from tensor slices method to create this our test data. So from this we created our test data. We now pass this into the model, and then we get our predictions. So if the prediction is greater than 0.5, it's a positive review, else it is a negative review, and then from this we could return our output. So that's it. We also have this requirements.txt. So that's it. We have this. It contains the versions for TensorFlow and for Google Cloud Storage, which we imported in the main.py file. So that's fine. We've specified the entry point. We could now go ahead and deploy. We have deployed this, where we have this error, function failed to deploy. So we'll click on this. Let's get into the details. We have here, this is likely due to a bug in the user code, error message, error memory limit exceeded. So that's the problem. We're getting it right here. And to solve this, what we'll do is we'll click on edit. There we go. We're gonna edit this. We have this runtime build and connection settings. Now the memory allocated here is too small, so depending on the model you will need to allocate more memory. So like now we just take this 2 GB, timeout 60, and that's fine. So we go ahead, click on next. That's fine. We deploy. Now also note that we could also, after clicking on next, we could also edit our code. So in case there's a bug in our code, we could simply edit it. So we deploy. This time around our model was successfully deployed, and we could go ahead and test it. So click on that. We go to testing. In here we'll simply specify review. We have the review. we have, for example, I love this movie very much. That's fine. And we test the function. And there we go. We have a positive review. We could also have, for example, we could say this movie is very interesting. Let's add some HTML tags. Say, for example, H1. We have that. Supposing we got this from some web page. So let's run that, and you see how with our vectorized layer, this is going to be taken off, and our model is going to work well. Again, we have a positive review. Let's now have this movie is very boring, for example. So let's take that off. Test our code. Here's the output. It says negative review, which is very correct since this is actually a negative review. Then if we get back to edit this function, you see here we have this trigger URL right here. So it's with this trigger URL that you could call this API, be it from a mobile application, web application, desktop application, or whatever software you have. So now, depending on the kind of software you have, let's say supposing you have in a mobile app, people could pass in a review, and then you call on this API, and then we get whether the review is a -1 or a +1 automatically, since we've embedded our model in the Google Cloud function.